Okay, all right, fine. So that was about non-local. Non-local is um, very straightforward. It's just that we need to understand it, and they keep changing the implementation. Previously, when I learned it, you didn't even have to declare this. Okay, you didn't even have to declare. You could simply make it non-local and you could print it here. You could have had the access to this one, but now they have maybe made that minor change wherein you have to have a value there assigned there. Okay, anyway, so decorators, again, decorators are the as I said, if you want to enhance the functionality of one function with another function, that is when you use decorators. Very simple example again I have taken here. If you divide two numbers 4 comma 2, you'll get 2.0 because 4 is getting divided by 2. Okay, so 2.0, which is fine. But if you divide 4 with 0, then we get a exception is raised as called error is raised called zero division error. We call it exception, not even error. Okay, we'll talk about this in errors and exception handling. So it's called division by zero. Okay, now basically you can't divide any number with zero. Okay, how do we handle that scenario is very simple again. A slight modification to this function is required. Okay, you are going to enhance, you are going to return the function as is, but you are going to decorate that function like we were seeing right at hello. So this way you are going to decorate that function. Now in this function, the decorator function, this decorator function has to accept another function. Okay, so this function will accept another function, and inside that you can write the logic as if b equals to 0, print cannot by divide, print cannot divide by 0 and return. And when you return the control back to this, when when you type return, that means controller is returned back to the innermost function, and when you type again return, control is reverted back to smart divide. Now smart divide is doing all of this. You don't have to write all this logic multiple times. You can just call smart divide and you can enhance this function's capability. Now when I pass 0, now I get cannot divide by 0 error here. Okay. So is this clear? Okay. Okay. All right. So pretty much that's it about decorators. Decorators you are going to use only in cases where you want to rewrite some code, existing code, you want to enhance their functionality. Okay, maybe then you will use decorators, but nobody uh, uses decorators in one go. In the very first attempt, if you are asked to write the code, nobody thinks of writing the code by enhancing using decorators unless and until they are following something called solid principles. This we will learn when we talk about ML engineering. It's not required now. What it means, I can tell you, is that we have certain code etiquettes that we have to follow. So that is what that solid principles talks about. Anyway, so you can write object oriented code, you can write classes, inside classes you can initialize some variables, and then inside functions. That should cover your 99.99% of your work. Only if there is existing code you want to, without altering that code, without altering or touching the existing code, you want to modify, on top of that you want to add additional functionality, that is when you write your own decorator function which is going to accept the already existing function and enhance its functionality. That way in the already existing logic that is using the current function will not be hampered. Okay, that will continue to run. The additional logic that you write, even if your additional logic is failing, the current logic that was already written won't fail, because if you divide, as you can see here, your existing function will continue to function as is. Okay, so that is when we use decorators, just to um, keep you informed. um, okay, all right. So if this is understood, then we can talk about closures. Okay. Now, uh, closures, even before closures, I think we have to talk about lambda function. So lambda function, I think we already have seen. Um, okay, okay, all right. So all this while you are defining a function, right? So left def add you are providing, and then either you are providing arguments or you are providing keyword arguments for users to provide, and then you are doing iterating over it, right? So total you are defining as 0 first, and then uh, you are using these for loops to iterate over, and then you are adding the sum and returning the sum. For simplicity, I will remove this quarks, but arguments I will keep. I was anyway missing the star. Anyway, so this is how we were writing. Okay. Now, what if there was a much easier way for us to write a function, okay, without defining a function? How do you write a function without defining a function? That is when we have something called lambda. Now, lambda is an anonymous function because there is no name specified anywhere. Okay, so for a function where you have this uh, def function, right, and then you have print hello world. You have, okay, function also I will replace with hello. So def hello world, you have hello world, and here if you type um, hello, you have hello world, you'll get hello world, right? So this function has a name called hello. This function has a name called add, arguments called args, and it's returning a value called total. So many things are there. But if you don't want to have this add, and don't want to define very complex logic, very in simple words you want to do, how would you do this? Using lambda keyword. So lambda keyword, we call it as anonymous function. If I just say lambda print hello world, okay, now this is a function, lambda function. Okay, um, and if I call this lambda function, so you'll have to call this lambda function, just assign this, and okay, okay, now um, the brackets are missing, so okay, so if you add the brackets, you will see that lambda function is being printed. This lambda function you have to learn it well. uh, lamp the most important here is, even if you uh, give less importance to decorators, even variable scopes for that matter, most important thing is functions, arguments, keyword arguments, and lambda function. These are very very important. When we start data analysis, these are going to be very 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 helpful. Okay, that's why learn lambda functions very well. So lambda function, if you want, I will repeat it again. Lambda function is a way for us to simplify the equation. Okay, the entire complex code that you write here, right, so these can be written in very simplistic way by using a lambda keyword, and you just have to specify this colon and do whatever the logic you want. Okay, so if I say lambda, this is my function, lambda function, for I in uh, good morning. Okay, um, print good morning. Okay, I would say no, I need one more colon. 1 second. So this may not work, but I will. Okay, lambda. Let me define a argument first. Lambda. Let's just say name. Not even this. Okay. Lambda argument. Let's just say print of hello. Come on. And this has to be assigned to some user. Okay. And I will call this as user. Okay, user of somebody. See, um, so the point I'm trying to make is lambda is a function which can execute some operations statements, and it can accept one variable, only one variable. Okay, so it can accept one variable, and to that variable you can do some operations like this. Print hello comma name. If I had to write this same thing using normal functions, I would write def hello, okay, which is here. Here I would pass person name person. Okay, here I would say, instead of this I would say person person, and I would make it as a formatted string. Here I would say Alice. Okay, that much would be the change. um, okay, so this is what it is. So lambda functions again. So we have already seen something called list comprehensions, right? List comprehensions. In list comprehensions, we have seen for I in good morning, good morning. Okay, you're returning I. This we have seen already. This we know. So now how lambda plays a role is, let's just say you want to apply a lambda function on a comprehension. So you can call a lambda function. One moment. No, okay, so this you can do it like this. Let's just say very simple function you want to write. For example, I, here I'll modify slightly. I would say I plus I, because addition is allowed on a string, right? So if I want to write a lambda function, lambda, okay, and then I would write some variable. You can take anything you want, x, okay, x plus x, okay, and then you have to enclose it in get, okay, for x in, okay, good morning. Yeah, so many times it has executed. Or even to simplify, for I in, instead of good morning, a range of 0 comma 5. Okay, um, if you assign this to var, no, even before assigning to var, so if you print, okay, so this way. So basically, I mean the same thing can be written in different way, right? So I mean however way you want to write, you can write, but I have used a function here. The same result can be written without function also. All we are doing is just wherever we are iterating from range 0 to 5, and then we are adding x to x, basically 0 to 0, 1 to 1, 2 to 2, 2 plus 2, 3 plus 3, 4 plus 4, that way. That is what we are doing here. Okay, this can be done simply by eliminating this also. So basically the point I'm trying to make here is you could use lambda functions inside comprehensions as well. That is what I'm trying to show you. If you use lambda functions inside comprehensions, then you will have to specify a return value. Here this is the return value, this is the lambda function name, this is the value which it accepts, and the operation it does. Lambda function name, value it accepts, okay, operation it does, return value, same as what you see here. Okay, function name, value it accepts, operation it does, return value. For this there is no return value, but there is operation, but here it is, there is return value. Okay, so same way for this also. um, okay, so lambda is going to come in handy for us when we use it with apply method in pandas. Okay, so it's going to help us a lot of ways. When we do data analysis, we will see that. Is this understood about lambda function? Okay, any doubts here? 595. Okay, see, the point I'm trying to illustrate is you can use lambda function directly as well and assign it to variable, and you can use lambda function inside the a list comprehension as well. You can use lambda function with apply method as well in pandas, which I will show you when we talk about data analysis. There it is going to help us. Essentially what I am trying to show here is lambda function, just like your normal function, it accepts an argument or a value which it is doing. Whatever you mention before this colon is a value it accepts. Okay, and this is the value it is returning. Okay, and the operation it is doing. So basically what is happening here is, what it means is, take the values from 0 to 5. When x becomes 0, x comes here, so x value becomes 0, value 0 comes to lambda. Now what lambda does is it starts to add 0 plus 0 and it returns 0. Okay, and that is how you get 0 here. Okay, so it is doing the operation returning the x value, so that's how you get 0. And then x value becomes 1 and 1 comes here, 1 plus 1 is added, 1 value is returned. Sorry, 1 plus 1 is becomes 2, 2 value is returned here. Like that process repeats up until x value becomes 8. Okay, final value becomes 8. The same thing could have been done just by passing x plus s without the lambda function. If you are specifying lambda functions, all these things have to be specified. If you are not going to specify lambda, you can directly call as well. Okay, for this example only. But for if you want to write complex logic, okay, wherein which you are accepting, let's just say you're doing data analysis on 3 rows, sorry, 3 columns. One column you want to take do something, and again another column you want to do something, another column you want to do something. So we have various ways of doing that, either apply method or np.where. So all those conditional methods are there. There you will end up using lambda, because you don't need to define the function name each and every time. Okay, so the main use of lambda function is it helps us in mitigating the need to reserve the memory for function names each time. Okay, although there is memory reserved for lambda, but you don't end up duplicating the effort for various functions, right? So when you define lambda, it knows it's anonymous function, it will do. Extra memory is not required. Okay, so that's what is happening here. Okay, all right. Mm-hmm. Like this, something like this, right? So you are taking the name, printing the, let's just say you have lambda, like, name comma age. You want right. Now, yeah, yeah, yeah. So, okay, irrespective of what I pass here, okay, if I want to return the age here, okay, var one of, let's just say you want to return, um, okay, some person named Alice, okay, let's just say 20, just for example. So you can get that. So you can, I have used two variables here, okay. So like this you can use, you can take age also, name also. Basically it depends on the way how it works is, see, it's a function, very simple to understand. Function by default accepts, you want how many values you want, you can pass here, okay. So if you want to pass even more values, name, age, address, or phone number, so that way email address, whatever the details you want to pass, you can pass. And but when you are calling, you have to make sure that you are passing those values, because whatever you pass here has to be returned, okay. So that's why in order to return, it has to fetch values from somewhere. Yes, yes. But you can write complex logic also, that's what I was trying to show here. See, you can do one operation, okay, based on conditions. Lambda you can do if, okay, again you can do for another column, you can do lambda elif, so that way also you can do. Ultimately it's just a function, okay. um, yeah, this use you will see in data analysis. When you notice there, you it will come very much handy. You will understand why we use lambda there. Okay. uh, all right, so we'll have to look at closures. So what's the time now? 10:48. So would you like to continue closures in the next class, or is it okay if we cover this now? Okay, right? Okay, all right. See, closures is also very simple concept. Okay. Now you see that global variable that we use, right? Now if I declare global c is equal to 20, I mean if I am defining outside the function, I don't have to declare this. But let's just say this global variable is declared somewhere. See, the problem with global variable is you can't do data hiding. Okay, so if I pass some function is there, okay, some function f1 is there. If I pass global c value or pi value, okay, this pi value will become available everywhere. If I someone wants to access pi, if pi dot they will manipulate pi equals to something, they'll do, it gets manipulated, okay. Although um, the value of pi will get manipulated outside, and it also is available for someone to access, okay. So data hiding concept is not applicable here. Data hiding means whatever the function, um, the operations are there inside the functions, they should get reserved to the function only, and only the return value should come out, nothing else should get leaked, okay. That is not available with global keyword, that is the problem, okay. In order to avoid that, okay, we use closures. Now closures is applicable for functions only, okay, that is one thing to remember. Second thing is, if you want to apply the same data hiding concept, okay, that you can use classes, object oriented. We'll talk about how data abstraction works and all of those, polymorphism, all of those things we'll learn in classes. But now let me write a function to just explain this. Let's just say multiply function you want, okay, multiply of some value I want, and inside this i would I would add a multiplier, okay. So with what value you want to multiply, basically I'm just trying to multiply two numbers. That's all. It is, there is no additional complex thing here. and after multiplying I'm returning, okay, returning the function multiplier. Okay, very simple. Okay, when you do this, see what happens. If I want to multiply, okay, multiply multiply 3, it is a function, right? So multiply is a function. Inside a function there is another function. X value I have not passed, but if I assign this to some variable, okay, some var3, okay, and likewise I create another variable called var5 where I'm multiplying the numbers. Okay, so now if I say var3 of 9, what happened? See, did you notice what happened? I didn't have to call multiplier at all. I'm not touching multiplier. I'm not even passing a value to multiplier. I'm only interacting with multiply. And multiply, if you notice, apart from this function, it is only returning the multiplier, which is this function. Okay. So without modifying or touching or knowing what is happening inside multiplier, multiply I'm passing here as 3. This 3 is taken to multiplier. Now we are after 3 is taken to this multiplier, okay, um, this object is returned, but it is returned as a function. It is not at there is no operation performed yet. That's what happened. If I that's what happened, you get to see, right? If I type multiply of 3, it is a function. There is no nothing you can make out of this function basically. Okay, so there is a x value that is yet to be assigned. Now if I assign the complete function to a variable, and to that variable I'm not even passing the value to multiply, I'm passing the value called 9 to this variable. So this 9 and 3 gets multiplied and you ultimately get the answer as 27, which is what this is, x value. Basically you are passing x value by assigning this to certain variable. Okay, this multiply outer function you are assigning to some variable and interacting with that variable, not interacting with this innermost variable function, and able to get the end result by passing a value to that variable. This multiply is taking that value and passing that value to multiplier, and then finally multiplication is happening. Okay, likewise if you take var5 of 2, you get 10, because var5 is taking 5 value, which is your n value, and inside this var5 when we pass as 2, that 2 is being passed to multiplier. 5 into 2 you are being given the output. So this way you can hide the values. This way you can hide the function. If I write a function like this, okay, no one is going to know what is happening inside multiplier. Okay, absolutely whatever the operations you are doing here, writing the code, no one is going to know that. Only they would know multiply is a function that is being passed, which is assigned to a variable, and that is taking a value and doing the operation. Nothing what is happening inside multiplier is not going to be known. So this process is called data hiding, and this way of writing code is called as closure. Here var5 var3 are said to be closures. Okay, so basically you can do one more thing also. If you pass var5, okay, var5 of var3 of, let's just say, 2, you see what happened. Var5 was 5. Okay, var 5 was 5, var 3 was 3, 5 3 is a 15, into 2 is 30. So that's how you got. Okay, so this method of enclosing the functions as a part of variables is called as enclosing. And all these objects we have something called closure, closure special method that we will see when we talk about special methods. Okay, so if I type dir, so dir of var5. Okay, so somewhere here you will see this additional part. Okay, so that otherwise would not have been available. um, okay, let's just say var6, var6 is equal to some value. Okay, some value I'm defining. If I pass var6, okay, if you notice there is no closure there. You see, var6 is not declared as a, not being used as a closure, hence there is no closure. Here you can see this closure thing, right? So this will give us a tuple. So if I type var5 dot underscore underscore closure, okay, is not callable. Okay, fine. Okay, so it's okay, anyway, fine. So values are not accessible. So that is the difference. I will delete this part. So that's all about closures. So closures are mainly used for data hiding between classes. Sorry, between functions only. Okay, that you remember. Any doubts in this? Okay, so this is clear. Lambda is clear. So lambda will learn more. As you use more lambda more, you will learn more. Okay, and non-local is when you want to override x value defined in uppermost function with lowermost function value. That is when you use non-local. Global is when you want entire program to have access to your innermost variables of your functions. That is when you declare global. Okay, by default anything defined outside is already global. You don't have to declare global x. Okay, so that anyway is global. Okay, and arguments, if you pass anything called arcs or a b c d x y z with one star, if you pass it as one star, it is considered as a set of values that you are going to pass without this equal symbol. Okay, and these are stored in tuple. That I think I made mistake when I said these are stored in a list. They are stored in a tuple. Okay, sorry. um, so star arcs are stored in a tuple, but you can pass whatever the values you want, and your program accordingly, whatever the logic you write, so those operations will be done. And if you specify double star, it automatically becomes keyword arguments or quarks we use. Ideally, like I said, gentleman agreement is to use quarks. Again, all these rules are mentioned in pep8. If you search for pep8, you will get it. All these rules are mentioned in the pep8 of Python documentation. So here quarks, one thing to notice, it stores values as items, which means you will have to, when you call it, you'll have to specify what, specify with a equal assign to a variable. Okay, that's about it. um, and then functions, a function is very simple thing that encloses some complex logic, and logic that can avoid repetition of execution. As you could see here, range of 10, list of range of 10, good morning all, we had to write 3 times. Instead here we wrote it in here we wrote it very simply in just 2 lines, and we called it multiple times, right? So you can execute like that. So that's all about functions. Okay, functions and closures. Um, and tomorrow we will see generators. Okay, and generators, iterables, iterators, and we'll move on to classes. Okay, classes are very important, I would say. Once you master functions and classes, everything else is easy. See, this exception handling is very easy. Data classes is easy. PyTest is easy. Regex is like a very enjoyable uh, learning. Okay, OS module, there is nothing much here also. SQLities, you will interact with SQL. Okay, so working with files, that is also very easy. JSON, neater functions, function. Basically, everything rest is easy, but the only things is you have to grab these concepts of functions and classes. So if you could do this much, if you practice today after this class, then it would be very easy for you to learn Python.